Well, hello and welcome back. Um, this is kind of an optional lecture. This is something extra, but a lot of times when I work with all these software, I kind of struggle to understand exactly what's happening. Okay, so that's what this is for. Here's a scenario that the kind of thing that keeps me up at night. And we have agents. We have a lot of agents in agent sheets, right? I mean, every cell has an agent at least, and they're all doing their thing. So can those things interact in some way and make it so that what you want to happen doesn't happen? Let's make this real concrete. We're going to have two agents, and I'm going to call them righty and lefty. And righty is just going to start at some spot and keep moving to the right. Every step it moves to the right, okay, no matter what's going on. Lefty always moves to the left, but it does something extra. When it finds that it's directly over righty, it's going to stop the game and say, nope, no, this is done. Now, the question is, if we put them on the same line, they're going to collide, okay? They're going to be here, they're going to be coming along, boom, it's going to have a collision. That means that lefty should at some point find itself over righty and stop the game. Maybe, right? Because what happens when they get really close? Let's say that lefty is just to the right of righty, okay? And it checks. Is it on top of righty? No, it isn't. So it moves left. Righty goes, oh, I'm supposed to move right. It moves to the place where lefty used to be, okay? Now lefty checks to see if it's on top of righty, and it goes, no, I'm not. So it moves again. Righty keeps moving right, lefty keeps moving left. Collision was avoided. Can this happen? Okay, let's find out. Okay, so here we have the experiment. This is our worksheet, and we have our two agents. This is righty and this is lefty. Okay, you have the arrows kind of indicating which direction they move. This is just terrain for them to move over. And let's look at the code. This is our friend lefty over here. And what we see is that if ever finds itself stacked above or below, that's an important part, okay? Because we don't really know if it's I mean, it could be over righty, it could be underneath righty. We don't care, okay? Above or below. Righty, then we sound an explosion, we'll stop the simulation. Otherwise, it's going to keep moving as long as it sees a blank area. And even if it sees lefty, is going to go ahead and move. So it should be over it at some point, okay? And let's look at righty. And he just moves, okay? He just always moves right. So let's see what happens. Look at that. Okay, let's see it again. Yeah, they're completely missing each other. There's absolutely no effect. So let's step through it. They're getting closer, they're getting closer. This is the magical point, okay? But they cross. And the reason that they're crossing is because lefty does not see righty underneath it, so it decides to move. Righty simply always moves, and there's success. Okay, so that period of time when they should have overlapped doesn't actually happen. Somewhat of an anomaly. Well, that was interesting. So, is this a problem? If it's a problem, how do we fix it? The first thing I want to observe is that a lot of times it just flat out doesn't matter. Okay. The agents take their individual actions when they want to do them. Everything kind of works out. Now, sometimes it does make a difference, and one of the ways that we try to avoid this issue is by moving to a place that we know is what we want. So instead of checking to see whether, for example, righty is underneath us or above us, we check whether righty is in the cell that we're going to be moving into next, and we take the action at that point. So if it's sitting immediately to the right, to the left of us, we'll move left, and at that point, do whatever we're going to do, like stop the game. Okay. In this example here, we move to a piece of or pile of gold. We take it. We don't wait to see if we're on top of it. We simply say, "Oh, we got it," if we're next to it, and move. That seems to make the games work out fairly well. Okay. Even there, you can set up scenarios where what you're really doing is preventing people from escaping. Like, for example, even if you don't mean it, if the ghost is chasing Pac-Man, Pac-Man is sitting right there. The fact that the ghost is in that position keeps Pac-Man from moving there, even if the ghost won't be there next. it seems to work while playing most of the game. So we'll use that solution the rest of the course. Here's another question. We have these two guys moving towards each other to make a collision. What if they're both trying to kill each other? Surely one of them's going to win and the other one's going to lose. How does that work? Again, the beauty about programming is that we can actually find out. Okay, so let's try this experiment. What we have here is the same righty from before. He's just going to move to the right, kind of waiting to be attacked. This here is a new lefty, and let's see what's different about this lefty. What he's doing is, what we talked about, which is that instead of waiting to be on top of the enemy before it says, oh, I got him, it actually tries to see if the enemy is adjacent to it, and if it is, then it moves in that direction. So look at the behavior here. Not only do we move, but we also erase the thing that was to the left. Okay, so we erase the enemy, we move over, and we make a sound, stop the simulation. Other than that, we're just going to keep moving left. Okay, let's see what happens. Do you see that at the end? It actually came close to it and then grabbed it. Okay, yep, captures it every time. It seems to work fairly well. This is a much more robust solution than what we had before. So we should always do this. Okay. Now, I also want to consider what happens when we have more than one attacker. Okay. So let's try that experiment. Here we are. This is the same as before. This just attacks and moves to the left. This one moves to the right, but is also attacking as it moves to the right. They both have the same code, essentially, and notice that it tries to see if the enemy is to the right, erases to the right, moves to the right. So it's the same as what we had. Okay, let's see. Who's going to win? Lefty one again, lefty one again. Interesting. Okay, looks like lefty wins every time. Actually, that's not true. I've seen lefty lose, but it's very, very, very rare. So it seems like there's something having to do with timing. Okay. In fact, let's emphasize that. Here's what I'm going to do. I'm going to take our lefty and I'm going to move him. Okay. All I've done is I've changed the distance between these two. Let's run. Right wins. Okay. How could that be? Again, let me change the timing a little bit. Run. Righty wins again. In this situation, I've actually seen lefty win as well, but righty seems to win most of the time. So the bottom line is that there's a little bit of randomness in here. Yeah, we can't predict completely what's going to happen. That might be okay in a game situation. A lot of times it's okay in a simulation as well. Sometimes it may not be. You actually have to know the timing of everything taking place. For example, if you're doing something like the game of life, is really important that things happen in lockstep. Okay, we'll talk about ways to do that next week. In the meantime, I'm going to leave you with a question. We've seen what happens when we have attacking arrows coming in different directions for a collision. But we did the code so that it always checked, I'm going to get the guy that's to my left or to my right, not the version that says, I'm going to get you if I'm sitting on top of you. Okay. If we use that version, then maybe it makes a difference, because maybe as they're coming along, instead of avoiding the collision, one of them gets to be above the other. Again, which one? Somewhat random. That one's going to win. Will that make a difference? Will changing the distance between those make a difference in that case? I'm going to leave it up to you to experiment with that and see what you can find. I'll see you all again next week.